Now let's wait more. Gary.
Greetings, all.
Hi, Gary. How are you?
Oh, the adventure continues in no uncertain terms.
Yes.
I still exist in this peculiar situation where when I wake up in the morning, I don't know whether or not I should be hiring more lawyers, retiring, or just coming to terms with the fact that I may be running a space program that rivals that of many nation-state space agencies. And it's not an exercise in hubris. It's just an attempt to account for the facts on the ground. I've got a lunar mission, orbital mission, which ostensibly I'm the program manager for, a 12U CubeSat that has a number of novel aspects to the mission. Several other low Earth orbit, 6U CubeSats, which are built and are ready to either need the failure modes and effects analysis done on them because their brethren, the first one, was failed immediately after it was turned on in orbit. I'm just providing mission support for that, but they chose not to follow my instructions, uh, and so they're coming back saying, "Gosh, gee, can you rescue?" Determine whether or not the others are bricks or whether or not they can be fixed or parted out and rebuilt into something. Plus, NASA's threatening to, do something about our Space Act umbrella agreement, which deals with all the technology development, demonstration, and deployment missions we've been XISP Inc. has been working on, for the last decade, which used to be really fairly radical, and they are not so much anymore. So, you know, that's how my day plays out. How about yours?
If you will end in prison, we will make manifestations under the USA consulate all everywhere we are with big signs, free Gary Barnhard.
Yeah.
Okay. Okay.
Yeah.
Okay.
The the joke is that many years ago, the National Aeronautics and Space Administration came to the determination that it was better to have some control of my actions than to have me, as a free agent. But as I said, the adventure continues.
Hi, Werner. Hello.
Hi, hello, hello, hello.
Okay, so I think we can start this meeting of the transport, mining, industry, and orbital debris and NEOS committee. So,
And Adriano, question for you. Also booked simultaneously with this was something with Robert Katz in the 18th SDG. How is that being handled?
yes, well, today I scheduled a Zoom call for Friday, next Friday at 5 p.m. European time. I see that Frank White and Robert Katz already accepted. Maybe you haven't received the invitation by the Google
Yeah,
Calendar.
it's okay. So yeah, I'll figure out what's going on there. I may have the day wrong, so I'll figure it out.
Okay, okay. Let's okay. In case you cannot join, we can reschedule maybe for
Yeah,
the next week. But
yeah, I'm
so
here.
check it, and if you cannot, we can reschedule for another time or another day.
Mhm.
Okay.
I cannot participate because on this day, at this day, I'm in Berlin and I'm there on the conference, on a conference.
Okay, that will not be a meeting of the whole 18 SDG committee. It will be just the four of us, Bernard, Gary, Frank White, and Robert Katz, because we try to understand what to do with the 18 SDG coalition. I think I will. Yeah, what I will say is that I want to resign from. Well, I was never elected as a chair of the coalition. However, I acted like a chair, and I want to resign and to propose to this small committee to send a letter to the whole coalition to hold something like a congress and to elect a new chair of the coalition and to decide what to do in 2025. Something like that. This I reflected, and this will be my position. So, okay, but we will discuss next Friday or another day if Gary cannot be.
I'll be there, Adriano.
Okay, that's fine. Well, coming to this meeting today, maybe maybe Werner or Jerry has an idea of an agenda for this meeting. In my opinion, this meeting is the first of 2025 for this committee, and we should understand what we want to do. If we want to develop some other paper, and if yes, on which topic. Could be orbital debris or the asteroids or the transport means transport systems or mining or industrial. For instance, we had the Lagrange Space Factory paper done by Werner and presented at the IAC in Milan. Maybe we could imagine the next step, trying to understand which products could be produced in the Lagrange Space Factory. And so making some concept about where to take the raw materials, which kind of machinery will be needed to process the raw materials, and how to work and for what products and what will be the markets for these products and so on. I don't know. Maybe we can try to start understanding or making some ideas for that.
Yes, I think this would be a good idea. I have made some thoughts about the resources, the natural resources, about the asteroids, about near-Earth asteroids and so on. Maybe I have prepared 2 sheets of paper. Maybe I will show it to you and share the screen and share the screen if you want.
Yes, please.
Yeah, okay, I'll do that. I hope. A minute.
I want to premise that we also have a very beautiful work made by Gary on the architecture of a lunar habitat, and so maybe it can be also useful for this work.
So this is the last work of myself. I think you can see the screen.
Yes.
Yes, you can see the screen. So I have thought about what may be the next possible targets for asteroid mining. I've made here a very simple sketch with the sun and the earth and there is a so-called natural Earth satellite, or a quasi-satellite, which was detected in the year 2016. It is called 2016 H03. It has a diameter of approximately 100 meters, and it is about 20 million of kilometers from Earth in an Earth orbit. And the second one, which is, in my opinion, interesting for the next decades, is a so-called Earth Trojan's asteroid, which has been detected on the Lagrangian point L5 with
You mean the, sorry,
supposed, yeah.
one question. You mean the Earth-Sun Lagrange point, right?
Yes,
Okay.
yes, the Earth-Sun Lagrange point. It has an estimated diameter of about 300 meters, and it is, of course, 150 million kilometers from Earth. So what I tried is a rough estimation of the material sources of those two celestial bodies. I supposed an average asteroid bulk density of about 2 grams per cubic centimeter. First of all, the natural Earth satellites, most of them are supposed to be just 1 to 5 meters in diameter, so they are very small, and only the asteroid 2060 H03 has about 100 meters in diameter. This is this one I mentioned before. The volume is about 500,000 cubic meters, and it has approximately 1 million of metric tons. If we suppose that this celestial body has about at least 3% of metals, we would gain 31,000 metric tons of metal, maybe. Of course, this is an optimistic way.
Sorry, one question.
Yeah.
One question. Is this object in Earth orbit?
Yes, it is in Earth orbit.
But it is 20 million.
It's in Earth orbit. Yes.
20 million kilometers.
Yes, it is about 60 times the
moon distance.
Distance from the moon.
Okay.
Yeah. And it has been detected some years ago in the year 2016.
I didn't know it may exist such a distant orbits around Earth.
Yes, it is really existing, and it was detected so far. So the second point is the so-called Earth Trojans in the Lagrangian points L4 and L5 of the Sun-Earth system. Maybe there are some small Earth Trojans which haven't been yet detected, but this one has already been in the year 20 detected, and it is the so-called asteroid 2010 TK7, and it is supposed to be about 300 meters in diameter. So it may have about 28 millions of metric tons, and if we suppose that it has about 3% of metals, so we could gain over 800,000 metal metal metric tons. And the third point are the so-called near-Earth asteroids, which are encountering or are crossing the Earth. I have made the calculation for 6 examples. You can see it here. And we could gain a mass of 1.5 billion tons. If we assume 5% ore or metal, it would be approximately 75 million tons of metal. So these are my first considerations about material sources which we could achieve in the last, and I think the next decades, until the year or until the end of the century. So this was my very short
Quite interesting
presentation.
You say metal. There is a possibility to understand which metals are in these asteroids.
It is also some kind of suppose. I think no one knows exactly. It may be mostly nickel ion, maybe also other metals and other material which is interesting for industry and space.
And you said 3%. No, that was the
estimation for the metals.
3% of the wall composition.
Yes.
And what is the rest? The 97% of the asteroid.
The rest may be stones.
Okay.
Stones, silicate, and so on.
That will be useful, however.
Yes, it will be useful, of course, however, yes.
Very good. So, okay. So our exercise could be to try to figure those materials could be used for what? To produce what? I think we can take some design inputs from the Kraft-Ericke work on the lunar industrialization paper, where he mentions the products that can be produced from the moon raw materials. So
yes, maybe it is mostly material for building space stations and habitats and so on, and space industry.
Yes.
And so on.
Yes. Okay. That's fine.
So this is my work in progress now.
Werner, can you say any estimate of how long it would take to send a craft from Earth to either of these objects?
I think at least several months.
Yeah, I appreciate that.
Several months.
The problem being that being in the same orbit and roughly about the same distance from the sun as the Earth, it makes getting to them not quite so straightforward.
No. Yes, but maybe our first possible target will be the small asteroids which is surrounding Earth, which I mentioned first.
Yes. So if there are any objects at the Earth Moon, L4 and L5 points, in fact, could we draft a proposal for a space telescope to do some observation to see if they can be detected.
Yes, this we could propose. We could already make such a proposal, of course. I don't know whether there are special telescopes for this purpose, but of course we can also propose one, an additional telescope, maybe in space.
Targeted to detect useful asteroids.
Yes, yes.
Yes, that would be a good idea. Very good idea. Yes. Okay, following the question made by Jerry, which kind of spacecraft would be needed to reach the asteroids and to start working on mining them and to upload the extracted materials and to bring them to our industrial plant in L5. So
maybe the first spacecraft, maybe a manned spacecraft, and afterwards it could be a robotic spacecraft.
Yeah, because with current technology, once something has actually been set up on location and human activity involvement in that would be most efficient. But after that, robotic technology would allow a device to extract raw material from the body and then to process it and manufacture into multiple copies of certain components. And I'm sure that that would be more efficiently done robotically.
Yes, but I think in time there may be a constant flow of material between the asteroid and the Earth orbit.
Yes, yes, definitely.
yeah, and maybe the metals extracted from the asteroid could be used to build the spacecrafts too, or
For example, yeah.
parts of spacecraft and assembled, and the spacecraft to be assembled in the Lagrange Space Factory could be one of the production to produce spacecraft transport means.
For example, yes.
Cargos and everything. Yeah, that would be a great impulse to the self-sufficiency of the Lagrange communities and Moon communities too. Yeah.
With regards to manufacturing in space, if work is carried out under weightless conditions, that has some advantage because you can make alloys of materials that normally under gravity would separate into different levels, whereas in weightless they would be fully combined. So we could make metals that could not be made on the surface of Earth. We can also make foam metals, which couldn't be done on Earth. But there are other materials, such as sheet glass, which really need to be made under gravity, because on Earth we do that by floating the silicon on a layer of molten tin. So that needs gravity to keep them separate. So that could be done in a rotating structure that could provide simulated gravity. So
there's also the ability to go through, and if you can control the process well enough, you can change what it turns out to be the dominant forces. So if you have something that has an inclination or a tendency towards a more clearly defined crystalline structure or a more perfect crystalline structure, and you can control the time horizon of the reaction and its solidification, you can go and basically what you're doing is you're orchestrating different forces. You're quite right. Traditionally we've used gravity, okay, but one of the things that you do have, surface tension becomes a dominant force,
Yes.
in a microgravity environment. If you control the speed of solidification, you can get a much more perfect alignment. What they're discovering with respect to graphene is there were single layer sheets, but they discovered that you can make multi-layer sheets that come up with a more rigid structure and a much more organized, basically it isn't just a single sheet ordering of the molecules. There's a special alignment occurs between multiple sheets. So they basically
Yes,
what
and
you're orchestrating different dominant forces.
And I think also you can make very strong sorts of steel and aluminum in space.
There's a whole range of different potential,
yes, much stronger
composites, if you will, and alloys.
And
that
alloys,
you can
of course,
explore.
too. Yeah.
And what Jerry was referring to in terms of foam steels and foamed metals. A way of thinking of it is if you've ever seen what amounts to being a hexagonal lattice that it's been hogged out by a 6-axis milling machine. You can essentially do that on a molecular level by getting an alignment. The appropriate alignment if you can control the processes.
However, that's a very important concept that we can try to develop is that it could be the beginning of making spacecrafts that never need to go down to Earth.
Right.
Should be a spacecraft made for space transportation.
Right. There's also, we've looked at traditional, approaches to manufacturing of things that are launched. We've looked at beginning to look at additive manufacturing that could be occurring on orbit. But there's also what amounts to being, biomechanical manufacturing. Okay, if you look at, some of the organization of biological systems in terms of the projection of shells and things like that occur in different organisms, and different alignment of things, it can make a tremendous difference in terms of essentially if you could grow volumes. That's another interesting twist. Also, there's been recent work that is, this brings it closer to home for you, Adriano, exploring Roman concrete. Why in the hell has it worked so well for so long?
The ancient Roman concrete, the ancient concrete.
Yeah.
The ancient, from the old Roman Empire.
Yeah. There's it turns out that mixed in were certain chemicals that allow for the structure to realign itself when it breaks. So it's essentially, it incorporates a self-healing, aspect to it. So
Yeah.
there's, our notion of what constitutes a material to work with is something that, we may need to evolve.
Yeah, but no, but yeah, but I was now reflecting on the requirements of a space-to-space transport mean. One important requirement is that it doesn't need to be so robust to support the vibration of re-entering the atmosphere, and it doesn't need materials of shielding to re-enter the atmosphere, because we don't need to re-enter the atmosphere in that case. And therefore, a priority should be given to other requirements like the protection from micrometeoroids and the protection from the radiations and these kind of things. That not necessarily that would be the metal the best solution. We could think about
There's an interesting twist about that, Adriano.
mixing polymers with other elements, other mineral elements, to get a good protection wall, let me say, for this kind of spacecrafts. Yeah, another requirement could be to have a possibility to have big cargos to put in materials and mine it from asteroids, and or maybe ice from the cometoids and things like that. I don't know, but there is a completely new class of requirements to be imagined.
Yeah, an interesting twist on that is that whereas you have different loading when you're just doing space to space, transport. There's been one of the things that it's possible to do is if you want to protect something from loading, if it can be encapsulated in water, okay, you end up basically providing an alternate load path so it doesn't have to go through the structure. And it also provides, for radiation shielding, and it's something that you might like to take there anyway. So there's, different, basically there are different ways of looking at things, and I think what you need to do is look at the outcomes you're trying to achieve, and then with an open mind determine, hey, what's the best way? What are the ways available to achieve them, and which of those are more optimal than another for a particular application?
Yeah. I think we could try to start speculating on these things and putting something on paper, or in bits, more than paper.
I have also a question. Do you know if there are some institutes at universities who are dealing with this matter? Material sciences are a big section in the faculties of mechanics.
Yes, there are a lot of institutes.
Yes,
a lot of institutes around the Western world.
Also
in Russia and so on. Also in Russia and China and so on. There are a lot of institutes.
Yeah, yes, but they are specialized to this topic of space materials. I do not know. Space materials.
Yes, yeah. There are some industrial companies who are also dealing with these problems.
Yes,
more
I
than
know.
Universities.
Also, I don't know, in the universities, I think it's not a real a topic still now. I don't know.
It is as well as in America, and it is also in Austria a topic at the universities.
I know
For example, yeah.
the University of
Okay.
Maryland, College Park, both the aerospace engineering department, in the Department of Chemistry, and the Department of Physics and Astronomy have collaborated on and there's a strong material science program there as well. That's where I graduated from, combining aerospace with a structures orientation in material science for my undergraduate degree. There's been a strong interest, and I know the Space Systems Lab there, led by Dr. Dave Aiken, has been trying to take a very pragmatic view of how it is that you deal with space structures, and they have a large neutral buoyancy tank on campus that they use for a ongoing set of experiments. But one of the things that I think we can contribute to is by one, helping to establish some form of taxonomy or framework, drawing on the community of interest, and then help show how by various papers, show how the different areas of work can fit into the broader puzzle. The idea that any researcher in a field can encounter work where they can see where their work fits in to the broader framework is a path towards supporting coordination, cooperation, collaboration, as well as understanding the notion of competition.
And do you know is there a connection between these different institutes, or are they solely working?
I think we have to operate under the assumption that to date it's rather limited, that it is not that there isn't an organized focus there. But we have an opportunity. I think we have an opportunity to encourage drawing out that confluence of interests. We're seeing that in a number of different areas. One area of immediate concern is this notion of what constitutes sustainable infrastructure settlement. Okay, we don't have a definition that crosses borders, much less organizations well. NASA sure as hell hasn't figured it out. And it's not clear to me that ESA has, or and another way of viewing it is that what's the path, say, from the art that you want to blaze from the Artemis Accords to achieving off-world anthropologic space infrastructure settlements. What's that? How do you make that make that transition, if you will? That is something that begs the definition of a framework that crosses organizational boundaries.
Something that I'd like to comment on, going back to the previous mention of different types of materials for spacecraft, and ongoing from that, space stations. Sierra Space is planning space stations made of inflatable materials, which include a layer of Vectran, that's VECTRAN. This is twice as strong as Kevlar, and when the units are fully inflated, they are actually tougher than steel. So that's something of interest, certainly.
Have
It's
you
what
ever looked? Have you ever looked at what Kevlar looks like at a on a molecular level?
I'm sure I have seen it many years ago.
Yeah, a way of thinking of it is imagine a coil spring mattress, only instead of it being cylindrical coils, they're conical coils. Essentially conical springs, and that's why it's so good at stopping high energy.
Yeah. Yeah. So I'm envisaging the main modules on Island 0 probably having this Vectron layer as well. The initial Island 0 I'm currently assuming to be placed in low Earth equatorial orbit, which will have less radiation than in regular Earth orbits. But then also inflatable units are more resistant to radiation than metal ones in any case. But eventually, when we want to have an Island 0 unit out in L5, so beyond the Earth's magnetosphere, we will need strong radiation shielding.
Well, inflatable modules, inflatable materasso can be made of different materials. I have, well, not a direct knowledge of that, but I have discussed about that for many years when Marco Bernasconi was working with me. And he is the main European expert in inflatable materials. So he was discussing with ESA about several experiments to be conducted about different materials to build inflatable structures. It's not just one thing, it's a lot, is a world of different solutions depending from the requirements and the thickness you want to get and everything like that. So it's
Well, he's obviously the person to go to.
Out of science, yeah.
Could you let me have his contact details, Adriano?
Marco Bernasconi, yes. Well, it is maybe a couple of years that I don't hear from him, so I hope he's in good health. But I will, yes, I will try to get in connection with him again.
That would be good because I know that he'd be the person who could give the answers to a few questions that I have.
Yes, yes, yes.
Thank you.
By the way, he's in Switzerland, in Zurich, near Zurich. Hi, Walter.
Hi, I'm sorry that I was late. I had another conflict. But since this session's being recorded, I really like to.
Yes, it is recorded. You will see everything, of course. Well,
okay,
so
thanks.
we were discussing the first point of this meeting that was possible production to be made in a Lagrange space factory. And we were discussing about how to take which minerals we can take from near asteroids, and Werner has begun a study on that, on some asteroid that could be useful for that. We were also investigating to start working with concepts for space-to-space transport system. What will be the requirements, and et cetera, et cetera. So we arrived to think about to discuss about inflatable structures and other things useful to build this kind of spacecraft and space stations, of course. So, but because the problem is the same. Some objects that never need to go back to Earth to resist to the entry in the atmosphere, so they may have different requirements from the one that we see that are useful for Starship, for just to say one thing. So this was the first discussion for today.
Okay.
Another thing that it could be maybe initiated, because we just have, if we want to stay in 1 hour, we just have 15 minutes more, but we can also go a little bit longer, but not very much. Is the orbital debris. Now, on the orbital debris so far, we only developed some, let me say, political positions that we are promoting to increase the work on the recovering the orbital debris and possibly reusing the orbital debris in order to start an industrial production using orbital debris, for instance, aluminum to make fuel in space and other things like that. So I am, but as I repeat, so far we didn't play with the technical scientific concepts. I wonder if we could maybe make a step more and try to understand what is needed, what would be needed from a scientific and technical point of view to start recovering debris and reusing debris. So even in this case, to try conceptualize a first conceptualization of industrial processing in space of the debris, that would be, I think, another very worth activity.
I think there's some companies that are already looking at orbital debris removal. I've seen a couple of companies and conferences that talk about this, but I don't think they've implemented anything.
No, probably not. But yeah, we could try to develop a study to understand what is the state of the art in this this domain, and so trying to figure out maybe another paper, not for this year, because okay, not for IAC, let me say, because we already the submission is closed now for IAC, but we can, however, develop our papers for next year or for other users, not only for the IAF. So I think, yeah, if we can maybe today decide that we are beginning 2 new papers. One is on the industrial production in space, as we discussed it before, and the other one is industrial production in space using orbital debris. So maybe.
Okay.
I heard from a scientist at the university in Berlin that there are only a few parts of space debris which are worth to use for space activities, because the other materials of space debris is not so important. It's debris.
Yes, it also depends from the dimension, the size of the debris, because
Right.
the big wreckages are not so difficult to catch, even if there is a legal problem there, because as you know, in space, space is not like the sea. In the sea, you can recover any wreckage, and that is yours. If you because any wreckage in the sea could be a danger for navigation. Therefore, if you recover one, it's a worth action, and you get the property of that wreckage. In space, it is not so. So if you recover an old dismissed satellite, the owner of that satellite can bring you face to a court because the satellite was not yours, so you don't have the right to take it. So yeah, also Dennis and yeah, our lawyers, let me say, space lawyers could be useful in this discussion about the breeze, because there are these problems too. However, our aim could be just to try to advancing some conceptualization, if we are able to say something new in this domain, about not recovering. I think on the recovering we can just mention what others are doing, of course, but on the reutilization maybe we could write something interesting. I don't know. Also in this case, as a study is to be made to see what is the current literature on that point, and to understand if we can say something new, or even just to endorse the most promising activities that are going on.
An example of something that could be done is that the notion of Kevlar was discussed earlier. Okay, you could do the equivalent of essentially creating a Kevlar mat or funnel, if you will, that could be moved to a position where it gets in the way. And one method of dealing with orbital debris is significantly slowing it down. Now, it is possible that what you end up with is that a piece of debris might have enough energy on it that it could, may or may not be captured, by essentially, a Kevlar mat. But in many instances, you have a situation where it could be done, and you get bonus points if you can use the energy of impact to get you to the next place where you can be hit, by another piece of debris. And where this comes into play is when the Kevlar vest first became available in the United States as body armor. What my middle brother and I did is we took and shot a test pattern from a 22 caliber bullet up through a 50 caliber and we put that display on the counter of the place that was making the vests available. They sold out everything they could get. Okay, the idea that we could go through and demonstrate the behavior of systems at hyper velocities when impacting the equivalent of a Kevlar over a hybrid surface could be very useful. Essentially, it's like we're taking what we did for space station in terms of the multi-layer micrometeorite protection system, and extending that.
Okay, great. Well, okay, I think we had a good discussion of these 2 points today.
I think we have a third point, and I think the third point is that it is very interesting to look into the material sciences, the space material sciences, because I think there are needed a lot of innovations for space, and I think the industry and the universities who are dealing with material sciences, I think they must be interested in this new dimension of material sciences, because if we can produce other materials in space than on Earth, I think this is a profitable new section of material sciences.
Okay.
Did you understand? Did you understand me? My English is not so bad. Sorry.
3 points. Well, maybe 4 points. Okay, making a summary, we were discussing about the products of a Lagrange space factory. We were discussing about the space-to-space transport means. We were discussing about orbital debris industrial utilization and about new materials science.
Yes.
So we could maybe try to challenge some university about new materials for space, or new materials that can be done in space, can be produced in space, and all the connected concepts. Well,
Yeah.
anything else? If not, we can close this very interesting meeting. And yeah, I don't.
I have one thing. Are we gonna, do we need to start thinking about topics for papers for next year's IAC conference?
I would say not just yet.
2026, you mean?
Yeah, 2026.
Antalya, for Antalya. Yeah,
Okay.
it will be in Turkey, yeah, in Antalya. Yes, we can think about papers for 2026. Why not? Yes.
We should
Okay.
try. I think I will suggest that exactly for this, not this year, but for next year, this topic of the materials to be produced in space could be a good idea.
Mhm.
Should think about. I don't have ideas to propose now, but I think this is a good topic that we should work about during this year to be ready to present something next year in 2026.
Excellent. Yes. Okay, I was checking if we already scheduled the next meeting of this committee. Let me see.
Think in June it will be or something like that.
Is anybody planning on being in Sydney? For IAC?
17 the 17th June. 17th
Yes.
of June. Yes, okay.
Yes.
Good. In the next days, I will send a summary of this meeting. Maybe not tomorrow because I'm afraid I will be traveling, but let me say by the end of the week, I will do it.
Okay. Adriano, I've just put 2 posts in the chat.
Yeah.
In June is the international. Sorry, there's been some other things put it in before as well. The In Orbit Servicing, Assembly and Manufacturing Conference. It's taking place in Belfast, in Northern Ireland, in June.
Okay.
So I put details of that, including the URL, and further down, I've just posted the URL for anyone interested in submitting a paper.
Yes, very good. Excellent. Bene. Anything else?
Yeah. Is anybody else going to make it to IAC 2025 in Sydney?
I think Barnhard will be coming. Bernard Foink. And of course Susan Jevel from the States, and maybe someone else, our US members, but for sure there will be Bernard and Susan.
Yeah, and my wife and I will be there.
Okay, great. So if you like to also represent SRI in some tracks, you're welcome, of course.
Indeed, appreciate that.
Okay.
Okay, nice
Good.
talking with you all.
Thank you very much for participating to this meeting. And yeah, let's start working on the topics we mentioned and collecting, but putting together our thoughts and references and so on. The Google group is of course available for sharing what we will develop, and see you next time. Ad
Take
Astra.
care all.
Ad
See
astra.
you.
Ad astra.